find the derivative of function x squared inverse sine x. We know that inverse sine x is really hard to derive when it's an inverse function. So what we need to do is change the inverse function to a trigonometric function which is not inverse. To do that, we need first to apply the product rule. Because we have two functions, we will apply the product rule. The product rule states that d over dx f x times g of x is equal to f of x times g prime of x plus f of x, which is prime, times g of x. So now we need to apply this rule, which is the product rule, on this function. On this function we will say x squared times d over dx of the function, which we can say that the inverse sign is the g of x function and the x squared is the f of x function. So x times d over dx inverse sine x plus d over dx x squared times inverse sine x. So now what we're gonna do, we need to find the derivative of the inverse sine. So what we know that y is equal to sine inverse sine of x. So what we're gonna do is we will change the form of inverse sine to this form: sine y equal to x. In this kind of form, it's really easy to differentiate the sine y equals to x. So what we're gonna do now is we will apply the implicit differentiation. Sine y equal to x. Apply implicit differentiation. So d over dx sine y is equal to d over dx x. We know that the differentiation of sine y, we need to apply the chain rule. So the differentiation of sine is cosine, and since we have a y over here, it will be cosine y multiplied by dy over dx equal to the differentiation of x, which is 1. So now we differentiate the inverse sine to this form. Now we need to find dy over dx by dividing both sides by cosine y. We will get dy over dx is equal to 1 over cosine y. Now this still not satisfying, because I have the derivative in terms of y. As you can see, the derivative is still in terms of y, but I need it in terms of x. We know from the trigonometric identities that cosine y is equal to the principal root of 1 minus sine square y. So I can change the cosine y to this form, and then what we will get is dy over dx is equal to 1 over the principal root of 1 minus sine square y. Then we know that sine y is equal to x. So, and we have over here sine y. So I can change this sine y to x. So what I'm gonna do over here is dy over dx is equal to 1 over the root 1 minus x squared. Since we have a square over here, so when we change the sine y to x, we will write over here x and we will write the square above it, because sine, we have sine square y. So the final answer will be 1 over the root of 1 minus x squared. And this is the derivative of inverse sine x. So what I'm gonna do is apply it on the product rule I have over here. So now dy over dx is equal to 1 over the root of 1 minus x squared. So now, since we know that the derivative of inverse sine x is this, now we can go back to the product rule and solve it. We know that x squared times d over dx inverse sine 1x plus d over dx x squared times inverse sine x. So now we proceed with the solving. X squared, we write it as it is because it's not differentiable, times the derivative of inverse sine, which we already derived, and it's 1 over the root of 1 minus x squared, plus, because we have a plus over here, the derivative of x squared, which is 2x times inverse sine x. So what we're gonna do after this step, it's very simple. We need to simplify, since we already derived the whole function, the fx function and g of x function. Now we proceed with simplifying step. We need to simplify this. So x squared, we can just write it in this form: x squared 1 over root of 1 minus x squared plus the 2x times inverse sine, which equals to 2x sine inverse sine x. So this is the final answer for this, for fx equals to x squared inverse sine x, and the answer cannot be simplified more than that and cannot be solved more than that. This is the final answer. To be able to answer any kind of inverse trigonometric function, we need to change the inverse sine or inverse cosine or inverse tangent to a non-inverse trigonometric function to be able to derive it in a simple and easy way and derive it easily.